Hi everyone, good evening. Can you all hear me loud and clear? Yes. All the participants, just put it in the chat box quickly. Yes, no. Aditi, Apurva, Arpan, Atharva.
Good evening, sir.
Yeah, great. You
Yes,
guys
sir.
can hear me and I can hear you as well. Great. Awesome. The recording started. So let's begin with the bootcamp today. This is going to be a very, very interesting session that we're going to have today. We're going to learn about time series forecasting, all the fundamental concepts behind it. Why is it a challenge? How do we solve for it? Right? So first things first, has any one of you ever worked with a time series data set? Right? Anyone? Just wanting to make this a very interactive session so we all know where we are at. Has anyone worked with a time series data set, built a time series model?
No, sir.
Okay, no problem. Shayan has worked with it. Okay. Hi, Manjula. Okay, awesome. So let me try and explain what a time series forecasting problem is, right? So every now and then you might be coming across a problem where you have to predict some output. The prediction output could be a classification model, which is predicting a class, yes, no, true, false, good, bad, something like that. Or it can be a value which is in between a continuous range, which is usually called regression, where you're trying to predict a number, right? Time series forecasting is a regression problem. So you're trying to predict a number. But why is it different from normal forecasting, right? It is different because time series has something called as a pattern, right? And that pattern is repetitive, or in other words, it's called seasonal, or in other words, called cyclical. There is a pattern that is followed and a trend is observed which occurs in periodic intervals. It does not depend solely on input provided. It also depends on certain factors which are not in our control and are seasonal or cyclical. For example, the sales of mangoes. Does it depend on humans and humans only? Can we make sure that the sale of mangoes can be constant throughout the year? It's not going to happen, right? Because mangoes are produced in a certain season. They are can you guys hear me back? I think I was can you guys hear me? Who is the host? Yeah, Manjula, I think I'm getting muted again and again. You guys can hear me, right? Just a quick shout out, guys. Yes.
Yes,
You guys
sir.
can hear me? Great. Okay. So the idea is that there is an external force that creates a repetition or a seasonal or a cyclical trend in the data, which cannot be controlled by us directly, right? Which is why we choose a certain different set of models and a different set of strategies to convert our pattern prediction into a time series forecasting. All the other models in the world that we use, regression, classification, clustering, they all work on recognizing patterns. But there, the patterns have no trend. The patterns are not cyclical. In time series, it is, right? So a very common prediction problem you must have heard of: weather forecasting, revenue forecasting, GDP forecasting. It has a trend. For example, let's say you're trying to predict the GDP of India, right? India is a growing market. So there is a definite trend upward movement. We are moving in towards a better economy, right? But every 3 or 4 years, 10 years or 12 years, there is definitely a recession, because that's how the market cycle works. When people are very positive, they invest in the market, they buy more goods, they consume more goods. Once they consume more goods, the demand increases, so the prices increase. There comes a point where the prices have increased to such an amount that there are no more buyers left, so the absolute demand goes down. Because the demand goes down, the supply goes down, the cost goes down, people again start buying, right? So what happens is, it's something called as the market cycle, right? a very common understanding of this is the market cycle of anything. What is the market cycle? Just check this out. There is an economic cycle, there is accumulation, there is markup, there is markdown. A more relevant example, I think, which everyone will understand. Let me show you market cycle of supply and demand. Right? Yeah, you can look at this. There is a beginning, there is an accumulation where the product has been oversold. Now, because the product has been oversold, demand is now greater than supply. When the demand is greater than supply, more people are wanting to buy the thing, but there are less things, right? So people are going to pay an additional amount, right? For example, you will always be willing to pay some additional amount to buy a ticket to a concert that you want to go to, right? That's what people do. They buy the tickets, they hoard it, and then they later sell it in the black market because you can sell it for more than the MRP, right? That's what happens with a lot of agricultural goods as well. But once a lot of the product has been sold, right, it has been overbought. Now the demand has gone down. But when the demand had originally went up, the suppliers made sure that the supply also increases, right? Because suppliers are seeing that there is a higher demand, there is an advantage in pricing. I can sell the same product for a higher price. So they will produce more of the same product. Once they produce more of the same product and the people are not willing to buy it, the demand goes down. The demand goes down and the price goes down. So again, the markup reduces. Then the producers or manufacturers have to give you a discount to buy the product, right? So this is a general cycle, which is the market pricing cycle, right? But in general, there are other cycles as well. Right? In general, there are other cycles as well. And these are the kind of cycles that are tracked by the time series, right? Now, these are the basic libraries. I don't want to dive deeper into the libraries because most of you who are already here have been associated with Ivy or are trying to get inside the data science field. You must have heard about these libraries: NumPy, Pandas, Matplotlib, Seaborn. Just a quick check throughout the room. How many of you do not know about these libraries, are absolute newbies in Python? I'll try to just structure and alter my pace with respect to these things to fit everyone's need for part of the bootcamp. How many of you are absolutely newbies? So Prajwal does not has no idea about what we are doing. Maima, you can go ahead. I'll take questions immediately. Go ahead, please go ahead with your question. Do not wait for me.
So I said I mean that I am a newbie.
Okay, awesome. No problem. No problem. So guys, I will not be able to make you an intermediate Python developer or Python programmer in this bootcamp. That's not possible. We have like 20, 30 hours of sessions at Ivy just to get you to the place where you're super comfortable with Python. So that's definitely there. For that, you can contact with the Ivy team. They can help you a lot. They'll tell you about the courses, the other things. What I will do is I will give you an understanding of time series forecasting and just show you the Python code and give you fundamental ideas. Okay. I know Python, but I'm facing error to import the libraries. So Juhi, these are the fundamental libraries. So I don't think you should face any kind of error. I'd like to know about Matplotlib inline and warning. So Tushar, inline is basically whenever you want to plot the curves with the cells in a Jupyter notebook, right? So this is a Jupyter notebook. When you want to plot, right, and you plot with the cell, that's when you use Matplotlib inline. If you've ever used something known as Spider, right, which is another development environment for Python, you would see that the charts come in a separate dialog box, right? They will come as a separate page, right? So that's the idea behind Matplotlib inline. But post the JupyterLab extensions and the newer versions, I think you don't even need Matplotlib inline, so you can ignore it. Warnings is a library, Swarnava and Tushar. Warnings is such a library that there are a lot of times where there are version gaps. Okay, Pandas ka there came a version 0.2.6. Now there's a new version 0.2.8. So what they do is they don't completely disable the previous version. Okay, for a few versions that come after an older version, they tell you that this is what has changed from the previous version to the new version. And I'm giving you a warning right now. In the later versions of the Pandas library, we will block this, right? I'll quickly show you an example. Python warnings of version in pandas. How does it really look like? Right, this is a future warning. Oh my God, Stack Overflow is currently offline for maintenance. That's an amazing thing to see. Okay. Let me show you some image. Yes. Right. So warnings are certain things that look like this, the red color, right? They tell you that for a per. Yes.
Sorry to
Go ahead.
disturb you, sir. I don't
Yeah, go
think
ahead.
the warnings will be affecting the code. It will just be there, or will it affect the code?
No, it does not affect the code. That's what I'm saying. An error affects the code.
Yeah.
A warning informs you that certain things will be changing in the future. So you better alter your code to fit the latest version.
Oh, so importing the warnings might not be a compulsory or mandatory thing over there.
No, it's not a mandatory thing. It's just to make the things look beautiful, right? That's all.
Thank you.
Right. Cool. Also, so like in PyCharm, we don't use it because of this. Yes, Tushar, that's correct. Cool. So we've imported the libraries. So what are these libraries, guys? If you've ever done some amount of Python, if you've not, that's fine. I'm just giving you an introduction. There is NumPy, which is the numerical processing library of Python. It does array and matrix level calculations super fast. Pandas is the data processing and data manipulation library of Python, which is an amazing one. It has everything you need to process any kind of data. Matplotlib is the plotting library. Seaborn is another plotting library which is built on top of Matplotlib. So Matplotlib is a very raw thing. Seaborn is a very polished version of Matplotlib. Warnings is what we just displayed. Warnings is a library that helps you deal with warnings that come in between your code. Scikit-learn is the classical machine learning library of Python. So why do I say classical machine learning? Because there are other algorithms like deep learning, which have libraries like TensorFlow, PyTorch, right? But classical machine learning, which have algorithms like random forest, decision tree, Bayesian regression, gradient descent, all of those basic algorithms, they are a part of scikit-learn, right? So the first thing we do is we look at the data. So we have this consumer price index data. What is a consumer price index? To quickly summarize, suppose I take 10 essential elements that you must buy every month, okay? Or you must buy every year. For example, for survival in India, I will consider the price of, let's say, a toothpaste, right? What is the average toothpaste you buy? Let's say I'll consider the price of 1 kg of any of the rice or dal or atta, wheat or something. So you will basically combine the very fundamental necessities of human living into a basket. And that basket's price is called the consumer price index. How much does the consumer spend to live sustainably, right? Not in luxury, obviously, then the price can go high, but to live sustainably. Now, the understanding is it always has a base. What do we mean by base? Tushar, don't worry about all of those things. You'll get that later. Don't worry. Notebook, video, and everything. We'll do that later. Okay. Focus on the bootcamp right now. So in the consumer price index, you have a basket. In that basket, there is a base version. Base version means, let's say I started calculating the consumer price index in 2000, in the year 2000. So 2001's consumer price index will be dependent on 2000. Similarly, 2002 will depend on 2001. 2003 will depend on 2000. 2001 will depend on 2000. 2002 will also depend on 2000. 2003 will depend on 2000 again, right? So every value in the price index will depend on a base value. So, okay. So suppose if you mention 105, 105 is a 5% increase from base. 107 is a 7% increase from base. I hope that is clear to everyone. Guys online, everyone. Swarnavo, Tushar, Atharva, Juhi, Sonali, Prajwal. Yeah, great. That's the consumer price index. So what is this data? This data tells you by sector, rural or urban. Every city has a rural part, which is the internal part of the city, or the urban part, right, which is the main city. Then the year and month. So this is a month level data, very important to understand. Every time you get a time series data, your focus should be to clearly understand the time period. Is it a monthly, weekly, daily? What is the frequency of the data? And then by each state, you get the consumer price index, right? There are missing values in some states. That can be because of the data was not collected, or it was wrong, or anything else, right? But largely it will be because there is some data issue. But otherwise, wherever their data exists, we are going to consider it, right? So we have data.head and we have data.tail. So we have 267 data points. If you divide 267, you will see that it is still 2022 March, right? And it starts with 2011 January, right? So it starts with 2011 and it goes up till 2022 March, which is, the last time the data was collected, right? You can check the shape of the data. Now you'll see that from the data, I am going to filter out the data for one particular state. Let's say Andhra Pradesh. Okay. I pick the sector, which is rural and urban. I pick the year, which is the year-wise data set, month, which is the month-wise data set, and I pick the particular state, Andhra Pradesh. I'm not considering all the states right now because that's, more relevant for the example that we are going to do. So one state is enough. So let's say I filter my data. I've named it data underscore AP. This is a variable name attached to the filtered data. Okay. For everyone who's not, very used to in Python, I've just filtered my data set in such a way that it is giving me only Andhra Pradesh data. Okay. I've removed every other state. I will quickly check what is the number of missing values. So you can observe here that there is 262, right? This column says non-null count. Null means a missing value. So non-null means number of non-missing values. So out of 268 entries, there are 262 non-missing. So there are 6 missing values. Is that clear to everyone? Yes, no? Come on, guys. We have a lot of ground to cover. Let's do this. Just give a quick yes or no. Awesome. So now I look at the df.describe. By the way, these are all the individual steps we teach, we follow, and I, as an AI scientist working for a startup, I'll give you my introduction later. I just want to cover maximum content as much as possible. But this is what I do day in, day out, right? So I'm not teaching you something that is some theoretical or, ideal situation. This is what really goes into data science day in, day out. So then we do the describe. In the describe, we look at the count, the average, the standard deviation, the minimum value, the maximum value, the 25 percentile, 50 percentile, which is also called the median, 75 percentile, which is 3/4 of the data, right? And we look for cases if there are any kinds of outliers. So can you guys quickly look at this data and tell me if you see any outlier in the Andhra Pradesh column? Any outlier or something that does not look right? Anything? Come on, guys.
Minimum
Anything?
2011.
Yes, Kushal, that is correct. I think Kushal, that is correct. The minimum value is significantly low than the 25 percentile, as well as the entire data as well, right? So if your average value is 135 and your minimum value is 3.64, there's a huge gap between your minimum value and your average value. So we need to fix that when we are doing it, right? Quickly checking the sum of missing values. The dot is null gives you the true and false for each missing value. So if I want to quickly show you, this is what it gives. For whichever case there is a null value, it will be true. For whichever case there is no null value, it will be false. Since most of the values are actually there are no missing values. That's why you see false. If I do a dot
sum used?
Okay, so dot sum adds up. So in Python, the true and false are actually Boolean values, but they can be represented as integers 1 and 0 as well. So true can be mapped to 1, false can be mapped to 0. So if you add everything up, all the trues will add up. So you will see Andhra Pradesh has 6 cases where the missing values were true. That means there was an actual missing value. Make sense?
Got it.
Yeah, great. Now, so there are these 6 missing values. Can you guys quickly think of why these missing values exist? Any logic that you can define for these values to be missing? This is where the data brains comes in. This is not all technical. That is why you need some brains to be a data scientist as well. Think about it creatively, guys. Do not think about code. Do not think about technical aspects of it. Just
Maybe
think
due to
about it.
season.
If it was because of season, it would have happened every year. Why is it just 2021?
No, it was just in March, April, May, so I thought it was in season.
Yeah. Yes, it can be possible because of COVID or lockdown, right? I'll give you a hint here because this year should have been 2020, right? 2021 was not that big of a lockdown, right? 2020 was a great lockdown. Then 2021 also was a lockdown, right? So there was data collected for 2020, but data not collected for 2021. So yes, it could be a COVID lockdown situation. What will we do in this particular situation? We'd like to fill all these missing values, right? Why will we fill these missing values? Because we don't want a discontinuous time series. Every day, every month from 2011 to 2021, February, there is a data point. Suddenly for 6 data points, it's null, right? So there is a trend loss, which we don't want. So what we can do, there are multiple ways. Either we can replace these values with the previous month's value, which is a good enough estimation, or we can replace this value with the next month's value, or there are other solutions such that I can consider 2020 and 2022 May value and average it, right? So 2020, there was, let's say 100 sales. 2022, there was 110. So I'm assuming that 2021 will be 105, right? It's not exactly called mean imputation, Shashi, if what I'm talking is what you're saying. Mean imputation is simply take the average of the entire data set and then impute the value. Imputing means fixing the missing value. If you're saying that, that's also a solution. You can do median imputation also. Sir, can we take predicted values? You can, Shine. You can actually build a time series model till February 2021, and then predict for the next 6 months and replace it. That's also a possibility. Okay. Now, when you look for outliers, you can actually check out the outliers as well. So minimum value is usually an outlier, which you will see. Otherwise, you don't get to see a lot of outliers here. I can also use the Python plotting functionality, which I said CBond. Okay. We had written earlier import CBond as SNS. SNS is a short form for CBond. You can actually plot a box plot. What is a box plot? A box plot is a chart that helps you or informs you about outliers in your data. Okay. So whatever exists in between these two spaces is considered as non-outliers, and all the outliers are marked with this black triangular option, right? So this says that there are some outliers in the upward direction. There are some outliers in the bottom direction. Now, what is the reality of this situation? The reality is these I can ignore, okay, because they are not far beyond the maximum value, right? They're not far beyond the accepted maximum value. But this one I can't ignore because this is way beyond the accepted minimum value. Is that clear, everyone? Quick yes and no. Does that make sense? It's not clear to one. Tanu, it's not clear to you. Can you tell me why? I mean, that's obvious. If it's not clear, ask me the question where it's not clear. Which part of this is not clear to you? Tanu, can you speak on audio or are you going to write it? Minimum value part. Okay. So Tanu, what I'm saying here is, you see these black dots, these are very close to this line, right? So I am not wanting to manipulate the data artificially. If I handle them, I am going to be manipulating the data by my own bias. I can replace these values with the maximum value. I can, just delete these values, which again in time series will create discontinuity, right? So the idea is this side, I can go ahead with not handling it because they're not way beyond the maximum. But this is going to spoil my entire time series, right? So that's what I don't want to do, right? Swarnavo, they don't represent maximum or minimum. This is the minimum value and this is the maximum value, okay? They don't represent the actual maximum and minimum value. What they do is that these lines show you the non-outlier maximum value, okay? To give you an idea, there's something called as an interquartile range, which is used in the box plot. And the upper range is equal to quartile 3, which is 75 percentile of the data, plus 1.5 times interquartile range. Okay, so this value is this line. Okay, maximum value is obviously the data maximum value. Okay, right? We also do a histogram plot with matplotlib to observe what is the situation. So you can see there is a normal distribution of the rest of the data, but this particular data point is very critical, and it's actually troubling because it could easily be recorded in a wrong way, right? If you think about it, who is entering these data points? Humans, right? So humans can make errors, and because of that error, my entire time series might just completely drop. Okay, so I will try to observe this data point. I will quickly check the value less than 90, or you can say just the value less than 10. You will get only one value, which is this one, 3.64, right? So in 2021 November, only in the urban area of Andhra Pradesh, there was 3.64. Now my question is, if it would have happened in the rural area as well, I would have tried to find some explanation. But because it happened only in the urban area, it enhances my confidence that there is something wrong and I need to fix it. Does that make sense to all of you? Yes or no? Yeah. So what I'm going to do is, I know that the index is 259. Okay. So I will do df.log 257, let's say, to 261. I'm going to look at the data set that was close to this. So there is 3.64, 2021 November, right? 2021 November rural. So what I'm going to do is, I'm going to replace this value with the average urban CPI of the previous month and the next month. Okay, so urban 2021 October, urban 2021 December. So what are the indexes? 257 and 261. So what I will do is, I will get the value for CPI in 257 index, which is October, and I will get for 261, which is December. And then I will just add them up, divide by 2 to get the average value. And I am going to replace my data AP of the 259th index, which was a problematic index, with this average. When I do that, and if I quickly check, now my value is fixed. Okay, is everyone clear with this? I just did it in a very simple way to explain the problem. Otherwise, it can be done in a much more complicated way as well, right? I will also do the missing value fill. So there were, other than the wrong value, which was 3.64, or unusual value, there were 6 missing values as well, right? 6 missing values. I will fill them with a strategy called np.nan median. What does it do? It removes the missing value, calculates the median, and then it is going to fill the missing value in the data with the median value, right? And it's just going to do median imputation. Okay. And finally, I will check that there are no more missing values in my data. Okay. Now, sir, why are we taking Shan? I don't want to tell you that you should take median. Okay, you can take mean as well. Okay, it completely depends on the data set, on the different analysis you've done. Because we are doing time series forecasting, I'm not focusing on the data handling part more. Okay, we need to go to the time series section, the modeling section. But definitely, if you want to know more about how do we handle missing values, we can connect later. Okay, on this. If you have some questions, we can connect later. I just want to complete the thing first so that everyone has a larger idea. Then we'll definitely have a session for questions. Okay. Now, look at this data carefully, data AP. It has months in string format. Does everyone understand that? It has months in string format. Give me a quick answer. Can computers understand strings? Yes or no? Do computers have the ability to understand
No, sir.
strings?
No.
No, right? Because computers or any electronic devices only work in numerical form, right? In fact, not just numerical, they only work in signal form. The signal can be true or false, right? 0 or 1, binary communication, right?
Correct, sir.
Yeah. So a common processing step for all kinds of data sets in Python or in any other programming language of implementation is that you need to convert strings into numbers. Okay. So I've created a mapper here. January maps to 1, February to 2, and so on and so forth till December. And this mapper I am using to replace the month names with the numerical numbers, right? And this is your final output. January becomes 1, February becomes 2, and so on and so forth, right? Then I will do a transformation. What is the transformation? Understand carefully. We know that it is 2011 month 1, right? But when we show it to models, to algorithms, right, they do not understand this format because for them 2011 comma 01 is simply a string. Yes or no? 2011-01 is simply a string like Ivy, right? It's simply a string like Ivy. So we need to convert it to a relevant data type. What do we mean by converting to a relevant data type? Something that can be interpreted by the models. Okay, which is why we need to convert them into appropriate date time format. Okay, which is what we do here. We pick from every row of the data, we pick the year, we pick the month, and we assume that it is the first day of the month. You can assume it to be the last day of the month, does not change anything about the time series. Okay, so I'm assuming it is the first day, I'm picking the month from the row, I'm picking the year from the row, and I'm transforming my current data into a format which is acceptable by models. And once we do that, you will see that the date column appears like this. Okay, everyone clear about this? Yes, no? Guys online? Awesome. Now, what I want to do is I'm no longer interested in the year column, no longer interested in the month column. I'm also not interested in the sector column. I can do a sector-wise time series modeling, but for now, I'll just do it at the Andhra Pradesh level. Okay, because if you see, rural and urban are not very different from each other. They will usually follow a very common trend, right? They're not usually very different from each other. So we can assume that they're mostly constant, and we can group by the date column. When we group by the date column, what does it do? It aggregates your data for the Andhra Pradesh column, for the Andhra Pradesh Consumer Price Index column by a particular date. Now, obviously, for this particular date, 1st January 2011, I have 2 rows, right? I have 2 rows for Andhra Pradesh CPI 104, 103, right? I have 2 rows. Now, if I want to bring them to 1, I have to do some kind of numerical aggregation. What is the aggregation here? Median. It takes these 2 values, 104 and 103, finds out their median, and then creates the value. So you can see 103.5. Similarly, 106, 107, 106.5. So it takes the median, right? Now comes the interesting part. This is your data preparation. Data preparation completed. Now we come to a fundamentally very important concept called time series decomposition. Okay, this is critical, guys. So I want everyone to focus on this very, very much. This is something that will give you a larger understanding of the time series problem. Okay, so data, all the things that we have seen, we've already done it. We've converted it to an index. So it does not look like a column anymore. It looks like an index because the index can be the date and the value can be the actual value. Okay, it's very simple. Date is no longer there. 1 second. Yes. It was the order of execution, which is why it gave the error. Okay. Now look at this. I have simply plotted my data. I have simply plotted my data. Now let me quickly take a pen and give you guys an understanding of the problem. If you look at this, there is an increasing trend. Can you guys see that? Yes or no? There is an increasing trend of the data. So consumer price index at a large level is increasing. We all agree to that. For example, inflation must be maintained, but GDP must be increased, right? For example, cost must be maintained, but sales should be increased. Obviously, they don't happen like that. Whenever you want to increase sales or increase revenue, you might have to add a cost, but the difference should be larger, right? For 1 unit of addition in cost, you should get at least like 2 or 3 units of sales. That's how it works in the industry. But I hope the trend part is clear, right? With the trend part, there is some amount of seasonality also. Increase, decrease, increase, decrease, increase, decrease. Right? So let's say in Andhra Pradesh, people consume a certain set of goods that increase in price in particular months and decrease in price in particular months. Does that make sense, everyone? For example, I come from West Bengal, right? I come from Kolkata. So in Kolkata, rice consumption is very high, right? So rice consumption, because it is something that people from Kolkata eat throughout the year, but the price of rice is not constant throughout the year, right? At the time of actual, I would say the production of rice, whenever it happens, at that time, there's a lot of rice available. So the prices go down. And at the prices where rice production does not happen, right? That time the prices go higher because there is lesser availability. Again, supply and demand, right? So based on Andhra Pradesh Consumer Price Index, there are certain things that people consume at a particular point of time and every part of the year, right? So there is a fluctuation. And then there are obviously effects that we cannot understand, which is called the error, usually termed as an epsilon parameter. It's called an error, something that we cannot predict. Okay, it is going to be random, right? It's just going to be random, something like this. There is no understanding of this value. Okay, it can be low sometimes, it can be high sometimes. We cannot model it, right? There is only so much you can achieve with any prediction algorithm. In the end, you can never predict the exact value. Okay, I hope that makes sense, everyone. Yes, no? Right? So a time series data can be decomposed into different parts. What are these parts? It can be decomposed into trend. Trend is the larger level movement, the larger level direction of the entire data. Then there is seasonality, which is a repetition or a periodic pattern in the data, right? It's a periodic pattern in the data that you will observe, which is because of the periodic effect in the data, right? Which is why it is time series, right? And then there will be something called as residual, or which can also be called as error. Now, always remember, the residual error should have an average value of 0. If you do not see this, it is a very, very big problem. Your time series decomposition has not happened correctly if your residual does not have an average value close to 0. Because understand this carefully, if I have a constant error of 2 units, just assume, if I have a constant error of plus 2 units, why can't I just add those plus units in my prediction? Then my error will be 0. Does that make sense? Yes or no? Think about it. Suppose when I say a prediction of a value 100, and I tell you that my prediction error is 2%, what does that mean? The actual value can be 102, which is 2% in addition to 100, or it can be 98, which is 2% in reduction of the value 100. Does that make sense to everyone? Yes or no? So the error has to always be moving around 0. The average value of the error should be 0, right? The error cannot be constant. Because if the error is constant, I can just subtract or add it to my prediction and make the error 0, right? Which is why the residual should always move across the value 0. And this is what's happening here. Now, to decompose your time series data into different parts, trend, seasonality, and residuals, there is a simple library in Python, which is called the stats model. It has a time series analysis submodule, which has a seasonal decompose function. You pass your function, you pass your model type. We're going to come to model type in just 1 second, and you pass your period. Okay, period is your assumption of the fluctuation of the data. What is the period of seasonality of your data that you are passing here? Does that make sense? This is the value where you think the trend repeats itself. So I know that January 2011 trend will repeat in January 2012, then January 2013, then January 2014. In my data, the gap between January 2011 to January 2012 is 12 different rows. That is 12 different time periods, which is why I have put the time period here as 12. Yes, because it's monthly data. In a year, there are 12 months. If I make it to 6 months, you will see a problem. The first problem you will see is that the trend is no longer that well and the seasonality has increased. Okay. If I increase the time period to, let's say, 1, you will now see that my actual data and my trend is almost similar. So seasonal decomposition is 0, right? No seasonality observed whatsoever. If I do it 24, then you will see my trend is very smooth, right? My trend is very smooth, but there is a high fluctuation in seasonality, right? So using these parameters and changing this, I will be able to find out a decent periodicity in my data, right? Now, coming back to this model, additive, the other model type is called multiplicative. So let me quickly show you additive and multiplicative model. Okay, if you look at the images. So this chart is sufficient enough to give you an understanding. Okay, look at this chart. In this particular chart, the seasonality gets added to the trend, right? So what is the model? The model is equal to trend plus seasonality. The trend and the seasonality are added, right? In the multiplicative model, the seasonality impacts as a multiplier. So in this particular case, trend is multiplied with seasonality. Why am I saying trend multiplies with seasonality? Because you will see originally the seasonality had low effect. But with the movement in the higher value, higher order of trend, the seasonality started having higher effect. Does that make sense, everyone? An additive model, the seasonality impact is constant. It is not dependent on trend. In a multiplicative model, the seasonality's impact is directly proportional to the trend. You can see, for example, passengers in an aeroplane. Because the entire industry is moving in a very rapid pace, more number of passengers are coming every year. And at every part of the year, there is a seasonality, right? So a lot of people travel to their native places in holidays. So every year, the number of people travel is increasing in a multiplicative order, right? I hope that makes sense. Everyone, quick yes or no on the chat. If there's a question, I'd like to take one here. So, to choose the best time period, you will have to use some amount of domain expertise. You will have to know the kind of data you have. And second, you will try to do trial and error by changing different time periods and observing how your seasonality and trend curves are observed when you change different periods, right? Guys, is everyone clear with additive and multiplicative seasonality? Yes or no? Any questions here? Okay, just Sonali responded, so I'm assuming that others did not understand what's the case there. If there's any question, let me know. Okay, I think some people are not responding. For the ones who are saying yes, thanks guys. Okay, so if I try to change the model from additive to multiplicative, you will see a quick problem. The problem is there is a residual value of 1, which is a big problem. Okay, there is a constant residual value of 1. So Shayan, you can look at the data set, right? You can observe this and then you can decide if it's additive and multiplicative, or you can find out the residual value, and looking at the residual value, if it's not averaging out to 0, you will know that it's not supposed to be a multiplicative value. If it's a multiplicative model, your residual will be again close to 0. But because your residual is close to 1, that means it's wrong and additive model should be chosen. Does that make sense? Yeah. Okay. Now, I am going to split the data into training and testing. This is a very common step in machine learning. I mean, we cover all of those basic steps in our actual Ivy, Python, data science, and machine learning courses. But this is a very generic step, right? So you want to test the performance of your model on data that it has never seen before, right? Imagine one situation. You're giving an exam, and in the exam, the questions that have come are already present in the book or in the practice set that you had received from your instructor or teacher, right? Is that the right way to give an exam, or is that a right way to frame questions for an exam? No. Why? Because someone can easily memorize the answers and give the correct answers without understanding the concept. Does that make sense, guys? Everyone? Logical sense first, programmatic sense later. Let's talk about logic first. In every exam we are supposed to give, we should get brand new questions to test our knowledge and not test our memorization skills. Right? So that is why in the beginning of conducting any prediction problem, building any model, we eliminate or chuck out a data set completely, which we are not going to show to the model ever. This is brand new data set, fresh data set. Learning from this data set has never been happening, never been communicated to the model. The model will only learn from a particular data set, and it will predict on an absolutely new data set, right? For example, right now, if I ask you to predict the weather in the month of January 2022, right now, if I ask you to predict the weather in the month of January 2022, will you be building a prediction model or will you be just copying and pasting? Right? Most likely you will be copying and pasting because you know the actual values, they've already come. But if I ask you to predict the weather of August, you will have to genuinely build a model that will predict the weather of August, right? So that is why, to have the real knowledge incorporated in the model, we do a train test split where the testing data is never put inside. Okay, testing data is completely separated from the model. So we have our train and test. Now comes another very important concept. Okay, what is the concept? This is a concept of stationarity. Okay, stationarity is basically an assumption of all time series models. Okay, all time series models have an assumption called stationarity. Okay, what are the assumptions underlying stationarity? The first assumption is the average or the mean value or the expected value of the time series is constant throughout different periods. Okay, the standard deviation or the variance of the time series, I'll just copy and paste, is constant throughout different time periods. And finally, there is no seasonality in the data. Okay, so there are three aspects. This confirms stationarity, and once your time series is stationary, only then you can apply time series forecasting models, right? Now, if you quickly look at this, is this time series stationary? Yes or no? Think about it. Is this time series, our current time series, stationary? No. Let's quickly observe that. Let's consider a period between this and this. Considering a period between this and this. What is the average value? The average value will be something like this, right? If I consider this time period, again, randomly choosing a time period, what will be the average value? This will be an average value, right? Now, obviously, the average values are different in two time periods. So this violates the condition, the first condition of stationarity. Okay, this violates the first condition of stationarity. Now, let's say you have another time series plot like this. Okay, if you look at this, the average value is constant throughout. Guys, everyone understanding, not understanding? If you look at this time series, the average value is constant. Yeah, so the first expectation is met, right? But it is not stationary. Why? Because if you consider the standard deviation in this period, the standard deviation is very high, right? But if you consider the standard deviation in this period, the standard deviation is very low, right? So this violates the second condition. Okay. Now, if there is another time series, okay, which is like this, something like this, right? You will see that the average value is very constant. The standard deviation of the top and the bottom is very constant, but it has a seasonal trend in the data, which is why it will violate the third condition and it will not be accepted as a stationary time series, right? So what we are really expecting in a stationary time series is in between the value mu, which is the average value, it should have a distribution like this, right? With a very constant standard deviation, it should have a distribution like this with no seasonal. Okay, does that make sense, everyone? This is what we are really looking forward to when we talk about stationarity, right? Now, obviously, the raw data set of time series will never be stationary, okay, because it will have a trend, it will have a seasonality, and most curves are either going up or they're going down, usually, right? You'll find very rare curves that are stationary without doing any kind of processing, right? So this is one way to visually look at stationarity of the data. The second way is to do a statistical test called augmented Dickey-Fuller test, ADF test. What is the augmented Dickey-Fuller test? It is basically named after a scientist. When you conduct that augmented Dickey-Fuller test, you get something called as a p-value. Okay, the augmented Dickey-Fuller test is a hypothesis test. Okay, where the null hypothesis is that the time series is stationary. Okay, the null hypothesis is the time series is stationary, and the alternate hypothesis is the time series is not stationary, right? So if your p-value is less than 0.05, that means you have a 95% confidence that you accept the null hypothesis. That means the time series is stationary. I don't want to go into the very core statistics of it. It works on a unit root basis. You can find great videos online as well. But Dickey-Fuller test works on the basis of something called as a unit root. And the unit root is actually trying to define a autoregressive model, which is like y of t is equal to some value alpha multiplied by y of t minus 1. Okay, it actually represents that the current value of a time series is dependent on the previous value of the time series. If this happens, then your time series is not stationary, right? So this is the test that augmented Dickey-Fuller does. If the value is less than 0.05, you can say that you accept the null hypothesis and the time series is stationary. If the p-value is greater or equal to 0.05, you are going to reject the null hypothesis. And your time series is not stationary, and you will have to do some processing to make it suitable for modeling, right? So the augmented Dickey-Fuller test gives you the p-value, which you can see here. The p-value is greater than 0.05. If it is greater than 0.05, then we reject the null hypothesis. Time series is not stationary. Because it is not stationary, we'll do some processing on it in just a moment. There is another test called KPSS test. I don't want to pronounce it. It's very confusing. But this test works in the reverse way. Okay. For this particular test, the null hypothesis and alternate hypothesis are reversed. So here, if the p-value is greater than 0.05, then you accept the hypothesis. If it is less than 0.05, then you reject the hypothesis. So because the p-value is less than 0.05, this time it is not stationary because the two tests are reverse. Okay. So you can confirm using both these tests that your time series is not stationary. Now, what do we do to make it stationary? We apply a fundamental idea called differencing. Okay, understand this very carefully. Differencing methodology. Right? Suppose you have a upward trend time series data. Suppose you have a upward trend time series data. Right? It's something like 2, 3.5, 4, 5.5, 6.2, 7.5. Right? Now the average of different time periods will be very different. So it's non-stationary. But what if I just shift the data points like this? Right? And I make a new time series which will not have the first value. It will have null value in the first instance, 2 minus nothing, right? 2 minus nothing, then 3.5 minus 2. So it will be 1.5. Then 4 minus 3.5, that will be 0.5. Then 5.5 minus 4, right? So this will be again 1.5. Then again 6.2 minus 5.5, so 0.7. This value will have a very constant mean, will also have a very constant standard deviation, and will not have any seasonality. So we try to model this time series, right? So how does it work? You have a time series which is not stationary. Okay. You do a transformation, or you can also call that differencing on that time series, right? And you convert it into stationary, right? Now you model this stationary data using time series models, right? Now you predict the new values, the next time period values. Once you predict, you are actually predicting the transformed time series. You're not predicting the actual time series. You are using the transformed time series. Now you are going to reverse transform the time series to get the original data, right? Original format. This is how it usually works. Someone's using a pen. I'm not sure who is this. Who is this? I don't think I would get to know, but let me just clear all drawings. Can you guys see it on my screen? Everyone else? Can you guys see the drawing on my screen, or is it just me?
Now it's clear, sir.
I cleared it, but before it was available. It was that red thing was coming, right?
Yes, sir.
Okay. Whoever has done this, please don't do it. Okay. So the first transformation we do on our data set is called a Box-Cox transformation. Okay, it is named after two scientists. The title of one was Box, the title of other was Cox. What does Box-Cox transformation do? It transforms non-Gaussian distribution data into Gaussian distribution. Okay, another word for Gaussian distribution is normal distribution. Okay, so in a lot of models, they have an assumption called that the data should be normally distributed. Okay, does everyone know the normal distribution? It's called the normal distribution because it is the normal distribution. Suppose in India, you try to find out the distribution of heights of people or weights of people. You will always find that there are some people who are underweight, very underweight. There are some people who are overweight, very overweight, right? But the average population will be in between a range, right? So in India, that range can be like, 60 to 70, 80 kilos for males. For females, it can be a different curve, right? But the idea is most of the people will have a very familiar or common weight, and there will be edges which will have, extremities either in the lower side or on the upper side, right? So this is called a normal distribution. This is a requirement for a lot of machine learning, time series, and other types of models to function, right? Manjula, let me quickly take, I think, do we have time? Can we extend the session, or do we have a hard stop at 8?
You decide few minutes, how much time you need?
I think, I mean, it's a very broad topic. We have some more ground to cover. I
Of
just
course,
quickly
you
summarize
have
for you, right?
all the participants are there. Nobody has left. That shows that the topic is
Yeah.
really relevant to them. So I wouldn't say anything.
Okay. Yeah. So what I can do is I'll quickly summarize and wrap up in the next 10 minutes. For people who want to take the larger session, they can communicate with you and we can schedule another
Yeah,
larger
sure.
session. We can discuss in more detail, right? Great. So guys, box box transformation kya karte? There is other kinds of distributions. For example, there is something called as a power distribution. Okay. How does power distribution look like? Sorry. Power distribution curve. The power distribution curve looks like this, right? The power distribution curve looks like this. Just think about COVID cases, right? If you imagine the situation at the top, right? I mean, when the COVID is at the peak, how will it reduce? Will it directly go down to zero? It won't happen that way, right? It will slowly and steadily decrease to zero, right? In fact, in COVID, the case was actually normal. Initially, there were no cases. Then there were a lot of cases. Then it went down. But power curves are usually examples of situations where the initial is very high, and then there is a significant drop slowly and steadily, right? It happens a lot in stock market distributions, right? Some stocks will go to a very high value, and then they'll keep on decreasing, and ultimately it will just disrupt investors' wealth, right? So it happens in a lot of cases. You can find examples online, right? Okay. So box-box transformation, what does it do? It transforms any other distribution to a normal distribution, so it is useful for modeling, right? Once you have done your box-box transformation, we will also do something called as a differencing, right? So remember, this is your box-box data, and then I am doing a shift. I'm shifting it by 1 units. Okay, I'm shifting it by 1 unit, and then I'm taking a difference to get this data set, right? There is a slight peak here. That is because our original data had a huge drop here. Okay, we can choose to fix this. This can be an outlier. We can fix this, or we can let it be also. But you will now clearly see that after doing the differencing and box-box transformation, your data is now stationary, right? Visually, you can see it's stationary. If you want to do the ADF test again, you will see now your p-value is very less than zero. It's close to zero almost. Because it's less than zero, this means it's stationary. On the other hand, the KPSS test will be greater than 0.05 because it is a reverse order. Now your data set is again stationary. So stationarity test done. Once you've done the stationarity test, we will now think of building a model. I'm not going to dive deeper into the autocorrelation and partial autocorrelation function. It will take significant amount of time. But these two functions, partial autocorrelation and autocorrelation function, help us define the parameters of the model that we are trying to train. Okay, we are trying to train something called as an ARIMA model. What is an ARIMA model? It is an auto-regressive. We'll take questions in a minute, Shan. Okay, it is an auto-regressive integrated moving average model. Okay, auto-regressive means current value dependent on previous value. Okay, moving average means it depends on a lot of unknown cases or unpredictable inputs, right? And integrated means that we are choosing the difference based model. Okay, the differences of YT and YT minus 1, which is today's and yesterday's, the difference between them that we just saw the differencing model. So when we say that the current value depends on the previous value, we don't know how many previous values. It can depend on previous 1 month, it can depend on previous 3 months, it can depend on previous 10 months, right? So that is what the autocorrelation function helps you to find out. The autocorrelation function, the chart that you see here, helps you define what is the lag period, the impact of lag, the previous two time periods. Moving average is defined by the partial autocorrelation function. It tells you how many previous time periods should you consider to get a good estimation of today's value, right? And integrated is the difference-based model, which is the ARIMA model's primary functionality, right? So these three values, the order has been defined from the two charts that were above. We fit a ARIMA model, right? After fitting the model, we get the prediction. After doing the prediction, someone's audio, I'm getting a lot louder. Can you mute yourself, please? Sri Rama, can you mute yourself, please? Okay. So after doing the box transformation and everything, I try to predict the value. After predicting, I have to transform it back to my original value, for which I do a cumulative sum. And then I add my basic value, which is the initial value. So just remember, if the first day's value was 100 and the second day's value was 105, and I did the subtraction 105 minus 100, so the value is 5. But the core value, the base value of 100 needs to be added in the prediction, which is why the base value is getting added in each of the predictions, right? And once you do the prediction, you will see that it was able to predict properly for the two cases. This was the actual case, how the data was moving, right? And this was the next time period, right? This was the next time period, how it will move in the next session, right? And just like that, you can actually find out the prediction for the next 6 months. You can predict from the starting point plus the next 6 days of the ending point, which you can see the code here. Then again, transform it into the additional formats we need. And then you get the next 6 months prediction. Okay. So I apologize. There was a lot of content because time series modeling, honestly, 1 hour for time series modeling is less. But for anyone who wants a full session on time series modeling post that, please connect with the Ivy team. They will get in touch with you and schedule a more deeper dive into the time series modeling functionality. And we can definitely discuss. Now, anyone who wants to leave can leave. I'll give a quick introduction to myself. You can definitely find me on LinkedIn. My name is Pranjal Biyani. I've been teaching with Ivy for almost I think 2.5, 3 years now. Right? I've been with them for almost 3 years. Ivy, I'm a data science MLAI instructor. I work at Polymerize, which is a Singapore-based startup. We solve for the material sciences domain. We build AI products for the material sciences industry. And I'm absolutely in love with data science. I love machine learning applications of AI. I have spoken at a lot of interesting conferences such as PyData London, EuroPython Ireland. These are images from the same, right? So I've been in the field. I have a lot of interesting insights about the field, and I have been a regular instructor at Ivy. So definitely, I would suggest all of you to enjoy learning about data science concepts. And if you'd like to schedule a conversation with anyone from the Ivy team, go ahead. You can drop a contact. We'll have all the resources to connect with you. And I hope to see you sometime in my class. Okay. Have a great day, guys. Thank you. Stay safe. I apologize for the last minute, the delays. We could have covered another time, but I think a lot of people have hard stops, so I do not want to go over time. Right. If there are any questions,
I would like to thank everybody on behalf of Ivy. Thank you, participants. We look forward to meeting you again the last day of the bootcamp session, which is there tomorrow. I'm sure you have taken a lot of insights from today's session, which can be understood that the participants right from the start till the end, the same numbers were there. There was no reduction at all. Thank you, Pranjal, and looking forward again to have you in some future sessions. So good day and good night.
Thank you so much,
Right, guys.
Appreciate it.
Thank you. Request you all to fill the feedback form, please. That is very valuable for us.